Hi. My name is Jakub. I work at Google as a software engineer in security. I'm actually in Zurich, but I'm here in Prague quite often. So the biggest problem we have in web applications is that it's very easy to make a mistake. So these are some mistakes developers do because basically everything is a string, and the string is often executed as code, right? Based on the context. So for example, if you just print some variable and you expect it to be a number, but it's not, then you have a problem, right? If you dump this into a page and the developer thinks, okay, I'm just printing a number, what could go wrong? And the thing is that the variable actually may not be number, right? It might be something else. Or the same in JavaScript, if you just assign something to inner HTML, again, you have a problem. If the variable contains some HTML, you have the attacker is able to inject HTML into your page, which can lead to cross-site scripting, which is basically remote execution of the attacker's code in the context of your page. And there are many other contexts. Actually, oh, it doesn't work again. Okay, so just in DOM, in browsers, we identified 61 places where things can go wrong, right? And we try to teach developers to tell them about like all these places that are wrong, but it's just too easy to do a mistake. And even experienced people that know about XSS, everything, they still do mistakes, right? So this is not going to work. The way that works for us is basically forbidding all the dangerous APIs. So at Google, we compile all our code, and during the compilation, we have some checks, right? So for example, if you compile JavaScript and there's inner HTML assignment anywhere in the JavaScript, we just disallow it, right? The code won't compile. And this is true for like all platforms we have. So for templates, we only allow auto-escaping, which means that if you print some variable, it is escaped by the context where you print it, which means that if you print something in HTML, it gets escape for HTML, right? So the code couldn't execute. And the same is true for all other contexts, JavaScript, style, and so on. And we do this also on a server side. So you are not allowed to just print any string as an output because that could be dangerous as well. So what you can do on the server to actually send the HTML to the client is, again, you are allowed only to for example, use a safe template, which we can guarantee is safe. So I already mentioned that basically everything in web applications is a string, and the meaning of the string depends on the context. So we change this mental model, and we say that string is only plain text, right? Nothing else. We never do anything else with string than as in plain text, which means that if we print some string into HTML, we escape it. If we, I don't know, alert it in JavaScript, again, we convert it to string, and so on. And for the values that have some meaning, right, such as HTML or JavaScript or style, we created wrapper types, for example, safe HTML, safe script, and so on, which is basically very simple wrappers around string. So they contain one value, which is string. But the thing is that this value, the inner value of the safe HTML, is protected, and the developer couldn't access it directly, right? And there's only a provably safe way how to create safe HTML, which means that anywhere in the application, you can create safe HTML or the other type. We know that the contents of the safe HTML is safe because there are only safe methods how to create it. And then you can pass this safe HTML around your application. And when you need to use it, you call our API that accepts safe HTML and does something with it, right? So for example, if you want to assign inner HTML, we have API called Google safe set inner HTML, and it is the only place that is allowed to assign inner HTML. Everything else is forbidden, right? So if the code, if you compile the code, it doesn't allow you to use inner HTML anywhere else. We also have different means how to create safe HTML. So one is by escaping, one is by tag creation. Basically, you pass a tag name, attributes, and the contents, and we say if we check if this combination is safe. There are also two special conversions. One is unchecked conversion, which is basically for things like an output from sanitizer, where we sanitize HTML, check that it contains, for example, only bold and italic text and nothing else, and then we bless this as safe HTML because we can prove that the output of the sanitizer is safe. And there's one more conversion, which is legacy conversion, which is basically used during transition period, where we introduce a new API that is safe, and we want to ban the old API, right? So we convert everybody to provable safety if possible, or we use legacy conversion to convert them to the new API so that we can ban the old API. As I said, all code at Google is compiled, and we have hooks to all compilers to check if you don't use the dangerous constructs. Some special APIs, for example, the unchecked conversions, are visibility restricted, so that it means that if you want to call the unchecked conversion from your code, you couldn't depend on it directly, because you would need approval from a security reviewer that would allow you to depend on unchecked conversion directly. So this is the example of the visibility restriction. So let's say we have legacy conversion, and it allows only legacy users, which is a target in Bazel. This is a build system used at Google, which is now open sourced as Bazel. And so you have a target legacy users, and it defines some packages. And these are the packages that are allowed to use legacy conversions and nothing else. And if someone new wants to use a legacy conversion, he needs to add themselves to this package, and it triggers a security review, right? So only a security reviewer can approve this change. So nothing bad could happen if the security reviewer does their job. This is an example of the JavaScript conformance. So for the JavaScript compiler, we have rules. We have some hooks. We call this conformance proto, and by the conformance rules, you can define patterns that are disallowed. So this is an example banning inner HTML assignment. So if anybody tries to assign something to element prototype inner HTML, it will tell them that it's not possible, right? And it will suggest them what to use instead. There's also some whitelist. So for example, the file defining or the file using inner HTML is whitelisted and nothing else, right? So Google safe is only allowed to assign something to inner HTML and nobody else. We also transfer some data between the server and the client. Most servers do it using JSON, which is not very good because, again, everything is just a string, and you don't have any type information about whether it's something special or not. And it's also not very efficient, right? Because you need to transfer the names of the fields all the time. So at Google, we use protocol buffers, which is a more compact format, and it has type safety, which means that at the server side, you can generate safe HTML, transfer it in protocol buffer to the client, and the client can get safe HTML that was generated at the server, which means that you can pass data that were already sanitized on the server to the client and use them there directly. In protocol buffers, basically all fields are public. There are no private fields. So the field that actually transfers the value of the HTML string inside the safe HTML is called private do not access or else safe HTML wrap value. And if someone tries to access this value directly, again, it triggers a security review. And the security reviewer bans usage of this field, right? So during the switch, there are many unsafe APIs. I mentioned just in DOM there are 61 or more. So we are banning them like from the biggest ones to smaller ones, from the most used ones to smaller ones. And the banning process is actually pretty straightforward. First, you need to define a safe API. For the inner HTML example, you define a function that is only allowed to accept safe HTML. And then you need to convert basically all code base that you want to protect to the safe API, right? So we have some tools to do this. So for example, if you assigned just a string literal to inner HTML, and the string literal doesn't contain any HTML text or anything special, you can just convert it to element text content equals that string literal, right? You don't need to do anything special. So you can basically remove the inner HTML usage because it was not necessary in this context. So we convert what is possible, we convert to provable safety, and the instances that are not possible to convert to provable safety without much effort, then we use them, we use the legacy conversion for them. So we convert everything to the new safe API, eventually calling legacy conversions if that's necessary, and then we can ban the new pattern, which means that all new code couldn't use the unsafe API, right? All new code is protected. And the code is recycled pretty often, so the old code gets deleted and new code gets added all the time. So all new code needs to conform to our rules. So this is an example of how the data flow in the application looks like. So basically, the unsafe way is passing strings everywhere, and the sink is, for example, the inner HTML assignment, right? So if you at the sink you accept a string, you don't know where it comes from, right? And you need to track it to the place where it was created and check if it is safe, right? Or you can sanitize it on somewhere in the middle, right? So with passing strings, it's very hard to prove that something is safe. So the first step during refactoring is to allow only safe values in the sinks and create them somewhere up in the chain. And the ideal state is to create them at their inception, right? So where they was originally created, you assign safe HTML to them and pass it in your application, and then you can say all my application is safe. So I mentioned that we have some types like safe HTML and safe script and so on. This is open source as well. This is part of Closure library, so it's open source in JavaScript, and in templates we open source them as well. So they are called Closure templates, but it requires you to use our library, right? So what we are working on right now is to bring this to the web platform, which means that not just your compiler will enforce it, but also the browser. So there's a proposal to create trusted types, which is basically very similar to safe types. And the thing is that the browser will only allow inner HTML from the trusted types, which is pretty much the same concept, but it will be enforced at the browser level. So you can look it up. It's called trusted types. The Canary version of Chrome already supports it. So you can say in your application, I don't allow strings in any of these 61 dangerous contexts, and I require only trusted types there. So this hopefully will happen also at the web platform level, not just at your compiled code level. And this is not just about XSS. For example, the same concept is usable also in SQL. We use it in SQL as well. So if you want to build some query, the thing is that we use like prepared statements, and that we bind variables directly. But in usual API, in common APIs, nothing prevents you to construct the query, for example, by string concatenation, right? And to pass some user input directly into the query, right? So we prevent exactly this. So the query could be only either a string literal or it could be constructed by our safe SQL builder. So this is not just about XSS, it's about other attacks as well. And that's it. Thank you for your attention.